Margaret and David. And I also think that this kind of well-being and measurement theme is one that we will come back to in the future, or we are trying to. So anyway, today, hello, welcome. Greatly appreciate your time and attention. And we're going to start off our episode 2 of Cybernetics Live with Cybernetics and the Railway. And I think Jonathan, our great secretary, playing 2 roles tonight, is going to talk us through it. So hello, welcome, and over to you, Jonathan.
Okay, thank you, Peter. I'll just pop the agenda on screen, so it should be coming through. I'll just put that on present mode.
Perfect,
so,
thank you.
Thank you for the introduction, Peter. We're still trying to track down Brian, so John has kindly John has kindly offered to step into the breach and set some of the context. What we'll then do is go into each of the 3 PhD topics. So Corneliu, Matt, myself. So Corneliu is focused on input data and data under uncertainty, Matthew on modelling, and myself on cultural aspects. What we'll then do is similar to the Cybernetics Live session we had back in January. We're going to break out groups which will allow kind of smaller discussions. We'll run that for 25 minutes and then we'll come back into one group similar to kind of the sessions that we've had previously under the President series. And then just before 7 o'clock, we'll have final reflections and then close at 7. You'll have noticed I hit the record button, so that will be, we'll publish that out on our YouTube channel. If you've got any burning questions during the presentations, please put that in chat. And then anything else, please save for the breakout groups. But then when we get into the all group session at 6:25, that's when we'll do more of the kind of traditional free flowing kind of chat type of approach to things. John, are you okay if I pass to you to tee up for us? Let me stop.
Yes, please. Yeah, so you unshare and I shall share something in just a minute. So my opening joke, of course, is that I'm a replacement speaker service because we haven't got a bus. Brian is officially now due to pay us compensation for being late on the basis that it's more than 10 minutes. So and this is a long distance journey because it's a 2-hour journey between now and 7 o'clock. So heaven knows where Brian is. But he'll be somewhere about, and no doubt a text will appear with an enormous apology in it at some point of proceeding. And we'll all claim under Schedule 8, I think it is, for delayed services. So SARM, this all started, well, Brian and I have worked together on and off since 2012-13, originally doing some work around climate change and the railway, subsequently flood risk in the East Anglia region, and sitting in the Quaker Meeting House on Euston Road in about 2016-ish, 17, no more than that, 2019. We were discussing the challenges of using data in the railway to make better decisions, and how you might employ both technology and learning algorithms, for want of a better expression, to help the railway to become better at not just not failing, but also improving its service. And then in August 2020, Carmont happened. And for those of you who don't remember, Carmont was a train pushed off the tracks by a landslide, the landslide caused by a failing drain, the failing drain caused by a whole variety of factors, but we'll start with poor design, then we'll go to poor implementation, and then we'll go to dreadful management of the drain. So in effect, they built the drain upside down, and when it rained heavily on it, it exploded, and it exploded all over the track, and an Intercity 125 fell off, and I think 3 people, died in that particular incident. So so that gave a spur to Network Rail to think, what might we do about this? There's an overall multi-million-pound programme called the Weather Risk Task Force, which was based on a set of recommendations made by Dame Julia Slingo, with the idea that the railway could and should be better prepared for dealing with adverse weather. Recommendation 3 of the Weather Risk Task Force work was includes this wonderful thing that we've called the Seasonally Agnostic Railway Model. And the idea of SARM, as it's known colloquially, is to be able to advise the railway in advance that anticipated weather will have an adverse effect on its train running and give it the opportunity to either fix the damaging asset or warn the passengers, or quite commonly both. And so started out, we built a first very rough prototype in a spreadsheet so you could follow the logic all the way through. Bit of a nightmare. But what became apparent very early on in the conversation with our friends at Network Rail, and they've been great, was that the data quality that a 200-year-old railway rooted in pen and ink has is nothing short of appalling. Understanding of what that data means and its implications for the way that they run the railway, equally appalling. And I say these words, and I have used them to the industry itself and to Network Rail. And then their ability to convert data into actionable information is at best weak. So those three things became very apparent very early on in the process. Now, what I'm going to do now is leap to what we're trying to do by sharing a screen, and we'll put that up, and hopefully we can get a slideshow. And oh, interesting how it always puts things in the wrong place, doesn't it? So you should now be able to see a big thing called the SARM challenge. Yes, good. Okay, it's working. So on the left-hand side was the original question that we started to ask, which was, look, if we know what the weather begins to look like, we can have a seasonal weather range, a seasonal prediction about what the weather's likely to do. And the first thing we want to be able to do is actually validate that weather. So we want to be able to learn about how accurate the weather predictions are or aren't. Second thing we need to learn is, given that we've got the weather, we should know what the specification of the assets is, and we can then look at the performance of the railway in relation to those assets and determine whether or not the specification is fitted to the weather or not. And the third loop on the same thing is that we then need to know whether we actually did deliver the assets that met the specification and whether or not they failed or worked in practice. And the three boxes here, the green and the amber and the red, are basically saying, if it's all going well, we have a green performance, everything's good. We then get a degraded performance where we might run an alternative timetable or something, and then we have a failed performance when the trains actually have to stop. So that was kind of where we started in 2021 as a conceptual model of what we wanted to do. And if I move across then to the other diagram so I can see it, the thinking behind it was, look, we capture the information at the level of what's called an operational route section. That's a piece of track between two recognizable points on the railway, a junction or a station or a river crossing or something that a driver can recognize when traveling at line speed. And we can use the information gathered at that level to aggregate it to the level of a route, to a region, and the whole railway. So we can start to think about aggregating information for regulation and improvement across the whole railway. We can then distribute that information to something like real-time control. So we can push it out to the control centers and say, look, this is what's likely to happen over the coming days, do something about it now. And of course, we can also push it out to train operators, to services, and to passengers, so we can say, well, Dr. Kavalek, yeah, it's all very well, but your train's going to be 17 minutes late tonight, so why don't you go home early or whatever. So those two sort of core diagrams emerged very early in the process. And what we've been doing for the last however many years it's been now, feels like forever, 3 years probably, is building a series of prototypes. And we're currently, to my left, and you can't see it because I can't point the camera, is Dr. Dudley is working away at building the next generation of queries. So we have built now a prototype for the Western region, which deals with the whole timetable, weekday timetable from Monday to Friday, for the whole of the Paddington to Penzance route via the Berks and Hants line, which is the bit that runs close to my back garden. It's able to make a series of assertions about the impact of the weather on the assets, and the impact of the assets on train running speed, and the impact of train running speed on performance. So you've got a multiple step chain of events that says this weather is going to cause that asset to be compromised. That compromise imposes this speed limit on the trains. This speed limit on the trains imposes this delay on the service. To give you some idea, when the model runs for every operational route section, and there are something like 30 between Paddington and Penzance, there are something like 67,000 possible answers for every service every day. So it's a bit of a monster when it comes to mangling data. So that process of building and that prototyping is being now tested live with the folks in the Swindon Control, and we're doing good stuff with them. So that's all good and it's all working along nicely. But however, to go to the next stage, there are three things that we need to be able to do. We need to be able to understand how reliable, if you like, that's probably the right word, our decision making can be given the level of uncertainty around the data that we're working with. So we have sort of multiple pots of uncertain data. We have uncertain data about the weather, we have uncertain data about the standards of the assets, and we have uncertain data about the train running performance. So we've got three levels of uncertainty to play with. And consequently, one of the questions to me was, well, if we've got a 20,000 mile long, 60-yard railway running several thousand services a day, how good a decision can we actually philosophically make in relation to those levels of uncertainty? So what level of uncertainty do you apply to the uncertainty? That's one. Two is, given that we make some level of assertion and we feed the assertion, the results of the assertion back into the engine, so we make the machine learn, how on earth do you do that? Machine learning at scale across an entire network of railway, thousands of services every day, hundreds of thousands of assertions being made. The machine learning that's involved in that is quite extraordinary. It's certainly bigger than the server that sits in my office here. To my knowledge, nobody else is doing machine learning at that scale, at this sort of level of, let's call it accuracy, for want of a better expression, because we're trying to learn at the level of the individual operational route section in relation to the individual assets. So it becomes very, very big, very, very quickly. And the accuracy becomes quite important when you're feeding then out the information out. That's level two. And level three was, well, we are working with an organisation that employs directly 40,000 people, indirectly another 60,000, on whom many millions depend every day for their journeys. But it's an organisation that is rooted in writing things on pieces of paper, storing them in filing cabinets and retrieving them later, which draws heavily on past practice, past knowledge, past experience, past wisdom for the decisions it makes, and is unaccustomed to making decisions using machine-generated answers. So that then throws up a sort of a big question. How do you culturally get them to shift from ask Fred, he knows, to using an answer that is generated by a machine that, frankly, they probably wouldn't very much trust? So emerging out of those three things become three research projects. How good a decision can we make using the quality of data available? Hence we've got Corneliu. How do we do machine learning at scale? Matthew. And then how do we get the organisation to start thinking about using this information generated by this machine that it doesn't entirely understand because it isn't steam driven? How do we get to do that? And hence three research projects popped out of the woodwork. They're actually one research project, but each of them is so damn big you couldn't meaningfully blend them into one. And hence we have Corneliu and Matthew and Jonathan all now working away at their element of that problem, and seeking as best they can to integrate their thinking and ideas. And the common thread for me was, this is all about adaptation and learning. It's actually all about how we use information. It's all about fulfillment of purpose. It's all about cybernetics. That's me. Good intro, I think. Thank you. I think immediate obvious questions. I think, Jonathan, if anybody's got one, otherwise back to you.
Brilliant. That was brilliant, John. Can't see any questions in the chat. So unless anybody's got any burning questions, raise your hand now. Otherwise, we'll go straight to Corneliu. But brilliant. Thanks, John.
Oh, Margaret.
Oh, Margaret.
Of course. Hello. I'm quite interested. I don't know if you've come across Michael Levin's work. And he's basically a computational evolutionary biologist, and he's quite interested in how cells communicate, how they begin to form assemblies and cohere into structure. And what he's discovered is that it's not just the bottom-up signaling or the top-down DNA, RNA expressions, but there's this mesoscopic level of organization that occurs as a result of the bioelectrophysiological signaling that happens as a result of the gap junctions between the cells. And I was just thinking of your machine learning models. Number one, the scale of stuff. We also know that what the brain does is it kind of uses, inside all this complexity, it's got these kind of simple dynamical envelopes, if you like, which help to organize. They're simplified control structures or response structures or models or whatever you want to call them that actually do a quick and dirty of a pattern that you've got missing bits from, but is so similar, you're willing to do away with some of the error signals you're getting because it's, so that's another way, another cheap and dirty. And then the third one is a piece of interesting work I read from, I think it's Bar Ilan University in Israel, a chap called Cantor. And what he discovered, and this is relevant to machine learning directly, is in the way the neurons compute, it's not just in the interneuronal signaling. They actually do these broad, really good at broad scale, not deep, classification, categorization functions. And part of the architecture has to do with the actual structure of the dendron, dendrites, etc. It does computation along the pathway, not just between the connections.
Margaret,
Okay, so
really
I'll just
So those are three suggestions from biology.
So could
That's what I
you,
wanted to say.
Margaret, put the links into a chat? Because I can see the direct relevance immediately to particularly what Matthew's doing. So if you could put those references in there, that would be really helpful. And we can then sort of start to hear where the guys are at, because I don't think there was a particular question in there, but I think the points are well made, and so if we can just pick them up, then I think that would be useful for everybody to do a bit more reading and understanding of, if that's okay. And so Miguel, what's Miguel saying there? Insert. Okay, so we are making life even more complicated with gamification in there, Miguel. Yes, I would agree with you. That's a useful way of thinking about how we might do this. Jonathan, I think you should press on with the talks at this point, because we're going to each time.
Corneliu, we'll pass the microphone to you.
Thank you, Jonathan, and thank you, John, for the introduction. So hello, everyone. My name is Corneliu. I'm one of the researchers that deals with the first problem, and I'm trying to share my screen now.
Cool, that's coming through. That's coming through as a preview.
Yep. Is it a preview?
If you go into the top left-hand corner where it says display settings, yeah, that's better. If you go either present bottom right or, yeah, that's good enough. Yeah.
Right, I'll just go it like this way.
Cool. Thank you.
Right, so my PhD topic is about decision reliability using incomplete or inaccurate asset data. I'm currently in my second year. I've started at the same time with another one of our researchers who will continue after this this presentation. Now, in the limit of time, I will try to go to the background and the first year as quickly as possible, and then move to the steps I'm taking this year for the project. The start is because of the climate change, the complexity of managing major systems like transportation systems has increasingly become worse and more complex, and occurrences like severe weather, such as storms, floods, and heat waves predominantly impact the railway. Now, this has created an urgent need of infrastructure adaptation, resilient decision-making, and enhanced data governance. And it is essential that this new types of weather patterns and new types of weather data are mapped and assessed, and also assessed where can they fit into better. Now, one of the major accidents, well, one of the major events that has boosted this movement of digital transformation is the Stonehaven derailment, which after the investigation from the Department of Transport, it was actually discovered that the derailment itself was not directly created by climate change, but in fact was created by a wrongly built drainage system. And in turn, this has created this movement and of creating new digital tools that effectively manage the rail infrastructure, one of which is SARM, and this has already been introduced by John. And to get into my project, so the aim of my PhD is to basically explore decision-making under the conditions of data uncertainty, utilize the principle of cybernetics to transfer knowledge for enhancing decision reliability and system resilience. Now, these are the aims and objectives I've started in the first year. I've completed the first one. So in the first year, I've done a systematic literature review on decision-making under the uncertain data conditions. And then this year, I'm trying to construct a logic to categorize this data in levels of availability, reliability, and significance, and also to use this logic in trying to understand what the exact impact and disruptions are. So what does this mean? Well, this means that I'm looking at the ethical aspects related to using inaccurate and incomplete data. So look exactly on how ethical it is to take a certain decision. Also investigate the value of risk, probability of rightness in decision. So what is the trade-off basically between risk, savings, operational efficiency, and so on. And also, there are questions regarding the quality of decisions, the decision-making systems themselves, and the trust factor into new technologies. This is something that I've started with, so because I didn't have any knowledge of cybernetics before starting the PhD, this is kind of one of the first image that popped out for me and trying to understand and get into the world of cybernetics. Which then for me translated into something like this. So in the first 6 months of the PhD, this is what I was envisioning that my research is about and how I will use the cybernetics method. So basically for me, it meant that the cybernetics is a tool that enables me to tap into different other fields and then create a knowledge base that can be translated into an automated system or something else. And based on the review and the work in the first year, we've submitted a paper in Intelligent Transport Systems special issue. This is called Navigating Uncertainty, Cybernetics, and System Thinking as Enablers for Rail Infrastructure Resilience. And in short, what this is about, well, this is basically a review of decision-making under uncertainty in various fields, especially the ones that are connected or somehow similar to the rail industry. So fields that have open environment variables or incomplete data sets similar in structure. Now, one common theme, despite the diversity of the domains, is that they are all bound by a common thread and they all grapple with managing uncertainty in the decision-making processes. And obviously, lately, climate change has produced another layer into that uncertainty. To get to the papers that I needed to include into this review, I've created a search which was split into 4 categories. So decision-making, terms related to industry, similar terms or around uncertainty and incomplete data, and also weather and resilience. What the discussion and findings have proven is that despite the diverse responses to uncertainty, most researchers have concluded that there is a need of a holistic approach to address complex issues and systems, and also need to view a large system as a whole rather than in isolation. And also nowadays, solutions like AI, expert knowledge, and multi-criteria decision-making methodologies, for example, need to be combined into a larger framework. Another common theme that has popped out in different industries is the challenge of data management. So obviously, rail is not the only industry that is dealing with data uncertainty, especially in decision making. And in an intelligent railway infrastructure management system, well, we do need to deal with problems very swiftly. I have an image. Oh yeah, sorry, sticker. So this is kind of a visual conclusion, if you want, from the literature review itself. So there were different domains that had similar characteristics, such as maritime and shipping, emergency response, agriculture, things like renewable energy, aviation as well. And all of them dealt with their problems into uncertainty in a slightly different way, or even very different ways, using maybe machine learning, weather mapping, predictive modeling, all kinds of modeling actually, or in some cases, data integration and other strategies as well. And coming into this year, having that knowledge now, what should I do and how exactly should I go into this philosophical debate on how do we make decisions with incomplete information? And also, is it possible to actually make an automated system do the same? Some of the questions that I started with was how do we deal, also a bit is how do we deal with systems reluctant to change, and how do we trade off between risk, monetary value, time, efficiency, and customer satisfaction, which is the most important, or what is the right balance for us to make decisions. And also very important is how do we create and associate a reliability index or something of something similar to the decisions we provide to network rail with our system. And to do that, well, I planned this year, actually in the next couple of months, to conduct unstructured interviews with experts and decision makers, not only in the rail industry, but open to other industries as well, the ones that I've identified in the literature review, and then try to, after I collect this information, try to find patterns in the data and provide it a structure afterwards. Now, this year also, I've also conducted a research visit in Tokyo, in the International Project Laboratory, which is led by Professor Kato. They deal with all kinds of transport infrastructure and civil engineering, including rail. And I went there with a plan to get some information, especially from the rail companies there in Japan. How do they deal with problems and data uncertainty? Although the initial plan didn't really turn out how I wanted it to be, I still got a formal reply from the company with all my queries from the project. And some of these are here. So they have weather management systems in their companies. Oh, and I forgot to mention, this is from Tokyo Corporation, which is an urban and semi-urban train company in and around Tokyo. It's quite big. They deal with I think it's about 9 lines only in Tokyo, starting from the metro system to the rail system itself. So coming back to the information they gave me, so they do have weather management systems, and they are triggered by certain circumstances that have been exceeded. So maybe things like rainfall or wind speed, snow, or etc. Now, what was interesting in the information they gave me is that because they deal with a lot of natural disasters, they have this accident and disaster countermeasure headquarters established when something happens, which takes precedence in decision making. So basically, they have the authority above everyone when something happens. One of the problems which happens to them as well is because of malfunctioning sensors or incorrect information, they might have sometimes delayed speed restrictions and things around that. But from my understanding, that is quite rare. They also deal with a lot of data integration from various stakeholders like the weather services, infrastructure managers, and transport operators as well. They have innovative training approaches, so they build training programs and they try to increase the real-time response. They also use alternative data sources. So, for example, if a train driver might see something that is suspicious, they report it and include it into their data management system. Other interesting things is, for example, the cross-functional teams. I think that was very interesting. So they have a team that basically its purpose is to integrate other teams, which is quite strange, but I found it interesting. They're very good as well at customer satisfaction and customer information and information provision and so on. So they have a multitude of channels through which they communicate with the society and the customers of their lines. They provide information about disruptions, about alternatives. They try to maintain trust and transparency at all times. And they look at the customer as not only a number, but as a being. And next steps after I collect this data is to see what sort of structure I can provide to the decision making. And an interesting take to it is to look at critical safety incidents and see how people and professionals have dealt with situations in which they, in short, I think, had to go beyond the procedures and rely on their expertise or maybe instinct. I don't know, it depends on how they will respond. And some potential ways for me to do that and also analyze that is to go through something like narrative inquiries, grounded theory, case study research, or even an adaptation of the critical incident technique. Ethnographic analysis also popped up as a potential methodology with some papers there, and there are other methodologies that might be suitable for this sort of inquiry. Although it is difficult to decide now, especially with the scope of the interview, and I think after the interviews, a more focused approach on a single or a combination of methods can be done. Hope I haven't gone over time. Thank you, and questions or comments if you have. Thank you.
Okay, thank you, Corneliu. If there's any clarification questions, shout now. Any other comments or thoughts, hold that over for the breakout groups. So I think with that, yeah, Elena, I think you've got a clarification question. Yeah.
Yes, I wondered if this was only passenger rail that we were dealing with, or if it included freight.
Oh, John, you're on mute.
I did put an answer in the chat. We have one network in this country. We run freight on the same rails as we run passengers. The vast majority is passenger, not freight. But they share the same timetable, bizarrely.
Thank you. Okay, great. I think we'll pass to Matt then. Matt, the mic is yours, Matt.
Okay, hello. Can everyone hear me okay?
Yeah.
Great.
Okay, so I saw it was only 10 minutes on the schedule, so I didn't prepare any slides. I'll just briefly talk you through. So yes, hello, I'm Matthew. I've met a few of you, maybe not a few of you. I'm working on the machine learning aspects of the SARM. So when you're building a model of a system, it's all about capturing the variables and the relationships between the variables. So it's just really about finding those two things. And in a SARM, we're just trying to model the railway and the weather. There are a lot of variables. So there'll be things like the assets, the track, the trains, the weather at different locations. Those are going to be your variables. And there's going to be lots and lots of different relationships. So a simple one, for example, would be if there's more rain in this location, the trains will go slower in that location. So that's just a simple example of a relationship. Okay, so when we're building the model and we're trying to capture all the variables and all the relationships, the variables are, well, they're meant to be the easy part. They come directly from the data, which is captured straight from real world sensors and observation. So real world sensors will capture what is happening now and then, store it in some sort of form on a database somewhere, but that represents the variable in its truest form. So to capture the variables, all you really need is good quality data and all-encompassing data. But as you will hear in the SARM projects, that is a slight issue where some of the data is missing and some of it's unreliable. Okay, so then we come to the relationships. So how are we going to capture the relationships? Because they're usually really complex equations and they're not directly visible to us like the variables. So you can't just stick a sensor on and find a relationship. But they can be captured like metaphorically within parameters of a model. So the whole trick to machine learning is trying to find those optimal parameters. And that can be quite hard to do efficiently, and sometimes it makes it unpractical. So to create and find out what parameters you're going to be using, that's where you get into the learning processes. And to do that, you need an observation over time. So you need to observe the system over time so you can start to deduce what behavior it's having. And then once you have a list of observations through time and you have a segment of behavior of the system, you can do a trial and error process of building models and testing them to see what parameters best simulate and replicate that behavior. And then there you go, you'll have your model. So that's the main problem we're doing, or I'm trying to deal with the machine learning aspects in SARM, is trying to find the parameters efficiently and effectively. So the main problems with doing that in the SARM is that there are lots of variables and lots of relationships. You're dealing with the UK railway, and including the weather. There's lots and lots of different things. If you really want to be nitpicky, you can look at every single raindrop. Every single little piece of metal on the track could be a variable. But usually you operate on a higher level of abstraction to where you can be practical and realistic. So with all those millions and thousands of millions of variables and parameters we need to fit into the model, that learning process of trial and error can take a very long time. It could take, depending on what technologies you're using, it could take millions of years and you'll never do it. So we want to make sure that the learning is practical so we can actually achieve something. And that's where that scalability problem comes in. Another big problem in SARM with doing this kind of thing is the missing and unreliable data we're dealing with. So if we're basing our variables on the real world sense of data, if that data is incorrect, then the model will really struggle to have any way of differentiating it from reality, and it will take it exactly as it's said in the database. So unreliable data can drastically throw off the model's performance. and missing data as well. If it doesn't know it's there, then it will have no way of knowing it's there. So that's another big problem we'd have to address to make the model reliable and accurate enough to be practical. And then another big problem, the last one I'm thinking of, is that the interpretability. So a lot of the learning methods and the trial and error use a black box approach, and a lot of the models are black boxes. So, well, that's the thing, when you're trying to model such a big complex system, the model is going to be a big complex system. So once it's hard to open up and look inside of everything and see what every little bit does. So when there's faults and when there's problems, it's really hard to diagnose it in the model. And that's really not going to help with integrating it in the workings of Network Rail. So it would be nice to have the model and the learning process at least partly interpretable so they can trust it. And another thing that Jonathan will come on to later is the liability reasons as well. So if there is a major fault based on the decisions of SARM, who's going to be the one to point fingers at? And if it's just a big black box and you're pointing a finger at it, then you run into a few problems. So my main question to you guys tonight is, how would cybernetics be of any help to those problems? I'll kick you off with my initial thought. So my favorite cybernetic theory that I think could help drastically was from Ashby and about his homeostat. So in his theory of ultra stability, you can guarantee to find optimal parameters if you have enough entropy within the system. So if you have enough parts to your model inside for the trial and error, it will eventually guarantee to find the best parameters, which is nice. But the only problem with that, it will take a very, very long time, because it's just randomly trial and error, trying every single configuration, which can take 1 billion of years with the SARM. So then you get into the more modern things where you get into the hill climber approaches and the gradient descent, which is very similar to what Ashby was talking about with his homeostat. But instead of just having all of the random connections and trying them one by one, it only has one connection and modifies it over time using some cool statistics and maths, which makes it a lot more efficient. So it will find good parameters a lot quicker, but it's not guaranteed to find the best parameters. And still, with a very big system, it can take a very, very long time to run. So you run into the scalability issues again. So yeah, that's really what I've got to say for today. I'm open to all ears. If you have any questions now, I'm sure we'll go over them later in the breakout room as well.
Right, thanks, Matt. Any clarification questions? Any broader questions we can deal in the breakouts and the group chat, but any clarification questions at this stage? Okay. Brilliant. Okay, well, thanks, Matt. So I'll take you into my bit now. Let's get the slides on screen. Share screen. So PowerPoint should be coming through. Give me a thumbs up if you can see the PowerPoint. Okay, great. So let me just go back up one. So there's 4 topics I'll cover within this. So as John was saying, my PhD is focused on the whole people sociological aspect of this. So we could introduce SARM, but how do we get the organization to embrace that? The 4 topics I'll cover is, what do we mean when we use the term culture? What do we mean when we talk about culture change? this third area is where I start to zero in a bit more on a system and how do the users interact with that. And that picks up on a couple of points. The one that Matt was referring to, which is about the accountability of the end users. And also the point I think, Miguel, you were making about gamification, about how do you get the end users to engage with the system. And the last area is from the various bits of reading I've been doing through the literature survey, I'm kind of thinking on how do we start to link these areas together. So if we go into the first area, so as you'd expect, that there is no shortage of literature and people writing about culture. The author I focused on this slide is Edgar Schein, who I think is the most relevant starting point for this sort of question. Schein proposes a number of different lenses through which to look at organizational culture. Over on the left-hand side is one of those lenses where he makes the distinction between technical culture, and this is generally the stuff that is more tangible. It's the stuff that you can actually write down. So it's processes, it's systems, it's the stuff you can actually point at some kind of artifact, some kind of object or document. And the stuff in green, so the social culture. So this is basically what's going on in people's heads. And quite often when people use the term culture, it's generally the stuff in the green box is normally what they're referring to. One of the other structures Schein uses is this around it's kind of espoused values. This is where kind of companies will have in their annual report or in the poster in reception about, you know, we believe in teamwork. And quite often there's an aspirational aspect to that. Sometimes that isn't the reality. And Schein makes the point that once you've dug beyond the espoused values, you can see the visible artifacts, which is some of this stuff and also a bit of this stuff, the norms, what's the kind of rituals, practices of the organizations. But to properly understand the culture, you have to do quite a bit of digging and interrogation to get beyond the visible stuff to understand the real underlying DNA, to get down through the behaviors and into the values and beliefs. And quite often, there's a lot of history associated with that and influence of powerful leaders and events in an organization's history. But you kind of got to get down to this level to properly understand the culture. If you stop at this level, you run the risk of missing stuff. What I put in the middle of this slide is how I think, how I'm kind of looking at this through a cybernetic lens. So when I think about both of these, I can see that these are feedback loops. They're feedback loops from the previous iteration of doing something, whether it's signing a contract or onboarding a supplier or whatever. It's helping feedback knowledge and learning from one iteration to another. But the difference between the technical culture and the social culture is the technical culture is a lot more tangible and has, as I've called it, a medium dampening. You can change it faster. Social culture, particularly the really deep stuff, is less tangible, but it's really hard to change. And that's why going to the business section of a bookstore or Amazon, there's a whole raft of books on culture change or overcoming resistance to change. And it's because the social aspects are slower to change. And that kind of brings me on to my second area, which is what do we mean when we start to think about changing the bit in green, the social culture? And quite often the way the question is framed, there's a kind of assumption that the technical culture is the right thing, the change there is right, and the social culture just needs to catch up. And sometimes that is the case. But also, there are times where the social culture, and particularly at that values level, there is deep learning which we don't want to lose. And sometimes there's safety features in that, particularly if those deep values are around safety. So sometimes it's the more superficial stuff we want to change, but we don't want to change some of the deeper stuff. Or if we do, we need to be very conscious about some of the hazards with that. And this again, where I think cybernetics comes in, because to understand where there's a conflict between the two, which is the one that we need to change or rethink, I think this is where we need to anchor that back in cybernetic concepts of purpose, identity, and the environment, because quite often it's the environment that's changed. The purpose and identity may be the same, but which is sending us, which is more aligned actually with that environmental change. And it could be that a technical change isn't as well aligned with the environment as we think. And it's actually the technical change we need to rethink rather than the culture. But it's quite often the other way around. It is the culture, social culture we need to change. When we then start thinking in terms of change, I put 4 different levels. It could be at the overall organization culture that carries the greatest risk, but could be greatest reward. Down to we could be creating a very specific microculture. So for a particular activity, we may want to consciously behave in a way that is countercultural, but it's very much associated with that particular activity. I've called out in the middle of the slide the Post Office Horizon scandal, which is an example where the social culture was shouting a message back into the technical culture. There was a problem, but the technical culture was suppressing it. I think that's relevant in the next slide. So I'll go on to that, this third area. And this is why I've called out, as I put on the slide there, it's not just what the system does, it's what you, the end user, can see that it's doing too. So I've kind of put a couple of archetypes there. On the left-hand side is where there's limited end user visibility into a system. Horizon will be an example of that. System B would be where there's high user visibility. But if we kind of put Horizon on one side and assume that in both cases, these are well-designed, well-written, competent systems, the lack of visibility, certainly in my experience, causes end user reduction in accountability. So in the System A scenario, what tends to happen is the end user's accountability for what the system does erodes. You get the, well, system gave that answer. Don't look at me, look at the system for why it said that. System B, this archetype, user communities still tend to maintain a sense of ownership and engagement with the system, because where they need to, they can look in specific examples they can trace to. They shouldn't do that all the time, it's just not efficient. But in the cases where they do, they can look through and either reassure themselves or possibly spot where some business logic is now no longer appropriate because the business has moved on. If I now look at the fourth area, so this is where I'm starting to think about how do I start to relate culture, cybernetics, and I'm using VSM as this is one of the best articulations of cybernetics in an organizational context, not the only one, but certainly one that tends to resonate a lot with the stuff I've seen in practice, and systems development stages. So this is things like systems development life cycle, COBIT, Agile, there's a whole raft of methodologies of how you go about implementing a system. Now, in practice, each of these areas, there's been quite a lot of interaction over things that have happened in practice in organizations. What I'm looking at is how can we build some of this into a series of frameworks? So that's part of what I'm looking at in the PhD. I've articulated some examples from one of these legs. So on leg 3, how do we think about the VSM in systems development methodology? So I've just thought there about in terms of the design for change stage, how would systems 1, 2, 3, 4, and 5 interact in that whole dialogue around designing a change, and also implementation and sustainment. Again, how would the various systems under VSM, what's the kind of dialogue that I'd expect to see in and around that stage of a systems development stage? So those are the 4 areas. I'll stop if there, see if there's any clarification questions. So any clarification questions before we tee up the breakout conversations?
No clarifications, Jonathan, but I think you've got a lot more reading to do from the chat.
Right. Few references then. Looks like the literature survey isn't over. I sense the literature survey never quite ends. Cool. Great. Well, what I'll do, yeah, we've not got Isabel with us, so
2 questions, isn't it?
you can do the you and I can do the tee up. So let me go to the agenda.
One question, Jonathan.
Yeah, go on, Raoul. Yeah.
Your presentation is, in my view, very different to the other two. How are you bringing together the three into one project?
So Corneliu, Matt, and myself, it's roughly on a monthly basis, are basically meeting and sharing what we're doing, and that way working out. So like Matt was referencing one of the conversations that he and I have had about end user visibility and what it means in terms of liability or accountability. So that's the way we're doing it, Raoul, is through regular meetings. And then as we get closer to the kind of deliverables into Network Rail, then obviously we need to kind of tie more of that in. But that's how we're doing it at the moment. John and Peter, any thoughts you have on that question? John, you're on mute.
It'll work well. If I make myself, it works better. For me, although Network Rail are paying for all this stuff, what we've created with these three research projects is a teaching machine. And it's actually, Raoul and Corneliu and Matt and Jonathan are all learning for themselves. But what they're learning actually has to be fed back into the railway company to kind of say, okay, guys, here's some stuff you really need to think about at a very sophisticated level. Because at the moment they're not. They're sort of quite bureaucratic in the way that they function, and they I think struggle with the concept of the problem, let alone the possibility of its solution. So what these three guys are doing, so Matthew's bit will fall very directly into the model at some point. The other two dimensions of it are kind of saying, well, organization, you have to think about these things, you have to actually reflect on yourselves. So for me, there's an element of these things forcing the organization to reflect on what it wants to be and how it wants to be that organization. Whether we'll succeed in the long term, I don't know, but in the meanwhile we've had fun, and three guys will get PhDs out of it. But it will be challenging, because the organizational framework in which you have to land this stuff, I would argue we're operating at director level in terms of our main client, but there's an awful lot of directors in an organisation the size of Network Rail. They are probably more transient than you would expect in terms of their occupancy of role, and the railway is in a fairly turbulent state most of the time. So I think, for me, can we teach the railway something about itself? Can we force it to reflect? And at local level, the people we're working with in Swindon, which is the local sort of control centre to here, they are engaging with it, and they are thinking about it in a very, very different way, which is great. So from an operational point of view, fabulous. From a strategic point of view, you must be aware of the recent announcement of the draft railway bill, the Integrated Railway Board's proposal, which seeks to reintegrate the network infrastructure with the train services under a single guiding mind. I'm tempted to apply for the role, but I think I'm probably too old and not favoured enough by whoever happens to be in power at the moment. But it's kind of, that's the person that we want to use this to get to, almost at the point where we know who the controlling mind is going to be. Well, let's go and talk to them. They'll either listen or they won't. So that's a long and rambling answer, really, but it's a real challenge with an organisation this big, spending, what do they spend every year? £6 billion on various bits of the railway. And bluntly, they all think they know what they're doing. And when you turn up and point out the error of their ways, it's not top of the list of popularity, shall we say. Peter.
Yeah, I think all clear. I think that to say further on that, I think it's a case of keeping things simple. And so perhaps that's something we can come back to later. But effectively, knowing the limits of data, knowing the utility of data and machines, and then integrating that in the organization as the three talks. Jonathan, I think we're back to you and the breakouts.
Cool, thank you both.
I have a question for Matthew. Are you
Hello.
all right?
Hello, yes, I can hear.
Matthew, you talked about Ashby and homeostasis. Can you connect that with the views that Jonathan has expressed?
I can a little bit. I mean, every time we meet and Jonathan explains what he's been reading and going through, I sort of try and look at it in a way of the system with its variables and all the connections. So when he talks about culture, I'm not really sure what culture is, but to me it feels like a pattern of behaviors. So, and then a pattern of behaviors, because it keeps repeating, that's why it's a pattern. It must be stable at some point. So I would see culture as some sort of stability. So when you have to try and change the culture, you've got to break out of some stable point into a new one. That's what first comes to my head.
In any case, it is clear that there is something that I have missed in the presentation, but I'm not sure, Jonathan, whether you are suggesting this to go to the group discussions, the small groups. But
Yes.
perhaps the simple question is, have you discussed together what is the system?
I think we both agree that the system is SARM, so it would be the model. But then I would
not the
think,
railway system with people.
yeah, I would think,
with
yeah,
people
so
and structures and all of that.
yeah, so Jonathan is dealing with a bigger system, which is the real network rail with the people in it operating. Whereas I'm thinking more about just that, the technical model system.
I do realize that that is what has been going on. However, I get the picture that Jonathan is trying to stop me.
No. What I was going to say, Raoul, is one of the factors here is Corneliu and Matt started earlier than me. So there is an element of kind of time is a factor in this. So ideally would have had all three PhDs start at the same time. So time is, and like Matt was saying, I'm kind of thinking about the system around the system, which I think is your point, is where we're drawing our scope around the, if you like, system in focus.
Yeah, I think yes. So I think there's an element of what Jonathan, what Corneliu's work should be informing the design of the machine learning capability, and informing the model itself, which Pete Dudley and I are actually in the process of building. And then Jonathan's task is to help us work out how the hell to land the damn thing in the overall organization that's running a railway. That says, you know, here is a tool which you will learn to find useful. And so there's a almost a recursive element to it there, sort of, Raoul, that, you know, that there's the level of the socio-technical solution of the model, but then there's the landing it in the organization and making it work as the third dimension on that.
May I pop in?
Go, Margaret.
Thanks, Jonathan. My comment around your work, because I'm rather more familiar with the sort of stuff you're doing and becoming more familiar with the machine learning stuff, etc. So it struck me that you might actually find an area of cognitive anthropology very useful. It's called distributed cognition. It's an interactive mode. It's the way of trying to analyze how the socio-technical and the cultural, the behavioral interlink with the values and so on, and in terms of how the system works as an entire cognitive system. So that might give you a sort of methodology that you could abstract from
Okay.
without
Yeah.
having to monitor every tiny little embodied interaction as they do in some of the examples. The sort of primary driver of that research has been a chap called Hutchins, and he's very much a systems chap, ecological systems chap.
Okay.
So you'll find that very helpful. And I think, Matt, you would find that very interesting too. Just a quick gloss. I can send a paper to all of you. I'll send it to your WhatsApps and so on. And then have a look at his little introductory sort of talk on what he thinks a distributed system is. And it might help you cohere your 3 bodies of data and do a bit of a meta system on it.
Great. Thank you, Margaret. Yeah, if you can send that, that would be brilliant.
Push the go button and split us up, Jonathan. See what happens. Go on. Be brave.
Right. So let me just I'll just put the tee up slide. Let me just share that. There we go. Right. So I'll share this on the chat. Unfortunately, Isabel's not with us, but Isabel had used this set of prompts in breakout sessions in Arup, which was just kind of good kind of scene setting in terms of way to run these kind of free-flowing discussions in the breakouts. So not going to talk through that. You can kind of see the prompts there. In terms of the breakout questions, some of the feedback we had from the session we had at the end of January is that people may have found it useful to have a tee-up question. So we put a couple of alternatives there. More than welcome to look at both of them. So again, I'll put those 2 questions in the chat. So I'll put all that text in the chat. I will now, let's come back and I'll hit the button. The other bit of feedback was to try and have one of the presenters or organizing team in each of the breakouts, which won't be too difficult as the numbers are in our favor in that respect. So I'll assign it randomly. I'll aim for 3 breakout groups, and then I'll do a bit of course correction if we end up with all the facilitators, sorry, all the presenters
in one room.
So let me hit the button. Right. So basically, free-flowing conversation from the breakouts. So we've got just under 15 minutes till 5:02. If we need to, we can do the hand raise on either physically or on Zoom. But anybody want to go first?
I can tell what we were talking about in our room. I have a few things.
Go on, Matt. Yep.
So there are a few theories thrown around that I need to go and find. So something about reducing search space from brain of the firm. Something about a cyber filter. I think that's from Heart of the Enterprise. And then there was another thing we looked at. It's called a OODA loop, which is it's like kind of like a little framework for making decisions. And it's just something to look at and keep it, maybe use. You can adapt it if it's any good. So there's just a few theories we looked at. If there's any more you guys have, you can chuck them in the chat. But then we also talked a few more about what we could do to fix some of this stuff. So more data was a good point. I think more data is always going to be a good point when you're trying to build models. So you can capture the variables a lot better and more reliably. So one example we talked about was live feeds from the trains. Or you can have the closer you are to updating the data to when you're making the decision, the more accurate it's going to be. So live feeds is really good. And the trains are packed with technology and humans with their phones. So it's probably some way to get that. But then we also talked about, would we want to have any extra data? Because we want to keep it, there's one aspect of we want to keep it using the same data that the humans use right now, so that we can point out to Network Rail where they need to improve on their data. And then, yeah, I think one more point was about the grammar of systems. Apparently, you can figure out what's in a black box without breaking it open and looking inside of it. I think it has something to do with statistics. That's something I'm going to have to hunt down and look at. And it might help with Jonathan's work as well.
You can work out how a black box behaves when you prod it and make it respond, as opposed to knowing how it works, which is different.
Okay. That's mainly the points I wrote down.
That's pretty good. We also talked about the Shewhart cycle, and for those of you who've done quality literature stuff, statistical process control rested in being able to use the Shewhart cycle to drive improvement. So the learning mechanisms, the point being the learning mechanisms go back an awful long time, and there's an awful lot of good work out there that Matthew can build on to deal with the sort of uncertainty that's floating around. But yeah, pretty good coverage, Matt.
And one added one was when you're taking it back to network rail, consider Donella Meadows' 12 places to intervene as to what's good and what's not to actually take forward.
Brilliant.
So can I ask Matthew, what did you talk about Cyberfilter?
We didn't really go into it much. We just mentioned it's something worth looking at.
I'll rescue you here. It's basically when you're looking for the difference that makes a difference to where you've got a lot of the data coming in, you've got to be able to recognize where that data actually means something, and therefore that's your alerting signal, which can then be taken into the decision making of the OODA loop.
Right. I think the difference that makes a difference goes back to Bateson rather than to Beer. And the idea of Cyberfilter is interesting because it suggests that data produces indices, and these indices are distributed around the system. And that's where you find that there is a connection between data and people. Now, one of the things that I was thinking while I was in the group which I participated in was the idea of recursion. Now, recursion is the idea that data is not something that you can handle in totally open way. It has to have some structure. And that structure requires that we make a connection between the data that we generate and the basic responses that people can provide. And that is something that makes a connection between data and structure, an organizational structure. And that's the connection where you can see a Cyberfilter in connection to data in general and people in particular. So there is plenty to develop, and I think in the group I was participating, I made the point that I would like to see more of a methodological input to the different contributions that we have heard today. And that methodological aspect goes into aspects like the ones I have just mentioned. So I'm not going to say much more than that.
I think that's really helpful.
And I think that leads nicely into the idea of thresholds, because Matt would have to work out what's the threshold at which a human action has to take place, given.
Yeah, I think I'm just treating thresholds and parameters under the same name at the moment.
Yeah, don't, not yet.
The difference between information and action.
Nice one. Yeah. So yeah, that action part seems to be missing from the decision process of where the data becomes relevant, salient to the user of the rail, the driver. Let's put it just in simple terms. And so there has to be this accommodation, if you like, of the curve, of like where on the curve do you need to actually involve a human? Because
Yeah,
it's going
I
to
can
impact.
imagine most of the time there won't be an issue. So the model will be predicting away, throwing no errors, saying keep on going. So yeah,
Or
at some point you would have to alert them, highlight.
yeah, because then you got to say, look, how long is it going to take to get there? Am I okay within that time period, right? Which is a constantly moving thing. It's a really complex thing that you're doing, very complex. Yeah.
Yeah, I think live data feeds is going to be pretty essential.
Yeah, I think so too. Yeah.
So I will say, because Brian's not here, I think his initial plan was to try and predict 5 days into the future so that when you're trying to plan a journey for next week, you can figure out, and you'll be more informed when you're figuring stuff out.
But
So I think
if I explain that, Matt, the railway has a process called EWAT, Extreme Weather Adaptation Teleconference. And what they're doing is they're taking to the weather forecast for, what's today? It's Tuesday today. So they take the weather forecast for Saturday and try to work out what the impact will be on Saturday's services from the weather that we're forecasting for Saturday, but we're doing it today. And the idea is that over the next 4 days, you can take the dead badgers out the ground, or clean up the drains, hang up the overhead wires, etc., so that the trains can run on Saturday, or you can provide an information feed out to customers about which trains won't run. And that's particularly the case where you've got flood risk in certain parts of the network. The really interesting thing is they don't have any information about where the tracks are likely to flood, and the weather forecast doesn't help with it.
So you need altitude measures as well then? Surely?
They just, well, bluntly, they need to start using much richer sources of data for their assertions than they're currently able to use. But that's essentially why it's T. So what Brian wants is T+4, well, today plus 4 days, so they've got 4 days to plan how to run a railway in 4 days' time, so they can manage customer expectation and/or fix the assets that are vulnerable. And that's kind of where we're trying to go with this. But actually getting them to shift from Fred knows how to do it to some other form of decision making is going to be interesting. So
what you've got to do there, if you don't mind me popping in another coin or two, is you've got to actually really surprise them. So you've got to drive up the prediction errors in their mental models, and you've got to then drive them towards novelty and interest, curiosity.
well, this is where Robin comes in, because he will undoubtedly be able to, as will Richard, be able to tell you that Network Rail run the safest railway in Europe, if not the world. And so they see any change as potentially increasing risk. So Robin, there's sort of an interesting cultural challenge here that says, we know the way we do it causes a certain number of deaths. Changing the way we do it might increase the number of deaths or accidents. And so the perception of increased risk in the senior decision making. What's your thought?
I thought climate change was going to do that anyway.
Both and.
Interesting thing. Basically, if you want to change culture, you can't change the culture of decision making. It is the emergent property of the system, as I said in our subgroup. So you need to enable structural change in processes and physical infrastructure in order to enable the culture to emerge in the direction you want it to go to.
So how much of that is about the behaviors of senior leaders directing decisions towards a particular stance on safety.
Mm.
So how much of it is behavioural from which the new culture will emerge, as opposed to structural and rule-based?
I think that one person at the top of organisation, like a chief exec, saying we are going to do it this way, has zero impact on what actually happens in the operations.
Well, maybe the guy S whatever at the top, system at the top, can say do this. Whether they actually do it, I mean, I'm utterly intrigued, John, by the fact for the second time in several months there was a derailment, roughly the same place outside West London around 6 a.m. a few days ago, and people weren't told about it until, say, they hit Clapham Junction several hours later, rather than it coming out on the websites. And yeah, maybe they should just pay their website people a little bit more.
So we are dealing. This is the stupidity.
They keep getting signaling failure.
They separate. So we are dealing with primary delay to services caused by weather events.
Not by derailment.
If you get a body under a train or the train jumps the tracks, that's not our problem, Governor. And our whole, because somebody else somewhere else is dealing with that or not. The consequence for your train at Clapham, of course, is that, particularly commuter times, your primary delay of a vehicle has jumped the track and caused a primary delay to the service behind concatenates all the way down through the timetable. So it might be 24 hours before the system catches up, because they have to resolve the problem, then find the bypasses, then cancel the services and all the other stuff. And the customer never reaches the front of the queue in terms of information sharing.
So does the Japanese system work the same way?
You'd have to ask Corneliu, but essentially yes, but it's very small. So nine bits of rail in nine bits of a network in a confined city is a very much simpler problem than even if you take the line of route here. I can't remember how many stations are there. In excess of there's something in excess of 200 stations on the bit we're dealing with, which is sort of quite scary. So it's a much more complex, much more interactive problem than I see your hand, Jonathan, than a metropolitan-based network. Jonathan wants to take control. Tell us all to shut up and go home, I think.
Yes. We've only got 4 minutes left. So great. I can do a quick summary from Group 1. Any highlights from Group 3? Corneliu et al. You guys wanted to sling in?
I think in short, we looked at the customer kind of perspective as well. So the ticketing, the information provision. So for us, customers of the rail, what sort of information do we need? We know that delays are inevitable in certain situations, but actually, I think the consensus was that it's not necessarily the delay, but it's the lack of information about the delay itself that I think this kind of makes the customers upset. We also discussed about the kind of aim of SARM in terms of operational efficiency and so on. And what else? I think those are the kind of the main 2 topics that we touched on.
Thanks, Corneliu. Quick headlines from Group 1. So Raoul, you raised the point in Group 1 about having a data model and that integration between the 3 areas. We talked a bit about the different levels in network rail industry that would use this. Miguel, you made the point that there's an AI trial exercise going on with Heathrow air traffic control, and that might be a useful reference project for us to have a look at in terms of another project using AI in a kind of safety planning context. David, Malcolm, you were making the points, we touched on it in terms of the Clapham situation of the true end user. And I think there's an example, Malcolm, you gave of where trains will miss out a couple of stations, which causes a lot of pain for the end users who want to get off at those stations, but of course keeps the train running on time for the other stations, so it's less financial impact to the operator. And then again, we had a conversation, we linked back to our chat at the front of this meeting, was about politics And given the somewhat depressing state of politics, the appetite for our politicians to kind of get behind this project. But I'm kind of mindful of your comments, Robin, that sometimes it's not necessarily the top level that makes this happen.
Yeah. There are civil servants in the Home Office who are rather opposed to the Rwanda situation and are feeding things in to politicians, which might be arguable,
Mhm.
Yes.
fortunately.
Yes. Cool. Okay, we are nearly at 7 o'clock. Peter, John, any closing comments you guys want to make?
Mine's very short and simple, because Peter's the president. I'm very, very pleased with what you're doing. I'm delighted you've been able to share your work, and I look forward to continuing to work with you all over the next couple of years to get something worthwhile for the railway and something worthwhile for yourselves. But thank you.
Likewise, and thank you, John.
Yeah, okay. Thank you, John. Thank you, everyone. Rarely have I compiled a longer and more interesting looking reading list in a couple of hours. This is definitely the future of literature search, I think. Absolutely wonderful set of ideas to work with, and so much crammed in. So thank you to everyone. And I think fair to say we've got an extremely exciting agenda coming ahead. So looking forward to engaging with everyone more. Watch this space, as they say. Note that name, Randall. Randall, that's an email to open.
Yes, more events coming.
Thank you, everyone. Greatly
Brilliant.
appreciated.
Thank you all.
Thank you. Bye-bye.
Brilliant. Thank you.
Bye.
Really interesting.
Thank you.
Thank you, Will.
Bye-bye, everyone.
Well done, Matt.
Bye
Thank you.
then. Thanks, Matt.
Margaret, brilliant as usual. Thank you.
Thank you.
It's really interesting, thanks. Jonathan, give us a shout if you want anything. I'll send you an email because I'm doing loads of work on decision making and control and that sort of stuff. So